Report to the cloud. So modern software development enables speed. So what holds us back today is really the question that we need to answer. What is holding the DoD back from embracing the software pathway? Does anybody have an idea? A big class, so somebody ought to have an idea what's holding us back.
The culture? We have
Culture.
gotten used too much through time, right?
Yeah, it's culture, and what else is holding us back in the DoD?
Money.
Money.
Money, the PPP program, the process, right? Well, yeah, it's like we still haven't figured that out. We still have a money problem. The JSIDS thing, we like, okay, we'll figure that out, but let's just get going. We can skip it. We'll work out a process. I think they've worked out a fairly decent process in the JSIDS process to make sure the requirements folks are still in the loop. But yeah, our funding thing. So I mentioned, if I didn't mention, there is a panel reviewing the PPPE process. It was stood up by Congress, by the National Defense Authorization Act a couple years ago. Their report is due out in March. You know, if something is asked for by Congress, you know, will they take it? Will they basically change our PPP process, or at least give us some leeway on starting a program fast? So we'll see if that actually happens. So, you know, this is a software acquisition management class, and sometimes we need to look back in retrospective of these terms that we're using. So when we talk about software is like completed things, right? It's a piece of software. In the old days, they put it on a CD or a DVD and they'd send it to you in the mail, or you go pick it up at the store, right? TurboTax, right? You buy the DVD of it. That is software. What is programming? Anybody have a good idea or definition of programming? What is programming?
I would say programming is writing the code for that software to work.
Yeah, writing the code. As a mechanical engineer at Virginia Tech, this is what I learned. And I thought it was normal for all engineers to learn how to program. So I did Fortran 77. I mean, this is back in the Stone Ages, I guess now. And it was for engineering language, so we could program stuff. You can imagine, you know, today we have a whole discipline called computer science, computer engineers. Back then they didn't. They had electrical engineers and they had mechanical engineers. That's how far we've come. So programming, if I was to put it into maybe some definitions, programming is problem solving, right? There's some problem, there's something that we need, some sort of equation to calculate, something that we want on the other end. So programming is solving the problems that the customer or the user is expressing to us. So the programmers, the people that write the code, are trying to solve the problems that are put in front of them. Pretty interesting way to define it. I'm reading the chat too. Programming is communicating with the machine, right? We're writing code that tells the machine, the computer, to do something. Okay, right? To have the, you know, as we think about a lot of software and our user experience is what we see on the screen. The programmer is writing the code that when I click PowerPoint, it basically displays something like this. When I open Zoom, it does that, and it's telling the machine to do it. It's everything that the programmer has programmed and wrote the code for. That is basically the user experience. It's the things, the tools that we have. Programming is what makes the machine usable, our computer usable. The things in our car, our things in our home, all this stuff was written by programmers. It's imperfect, and it's always a work in progress. So the people that are writing the code are imperfect. The code they write is imperfect. And that's the reason we set up the checks on how do we do the testing? How do we make sure that we catch all the bugs that have been written? But primarily, if there's something wrong with the software, you can basically push it all the way back either to the architect who designed it or the programmers who coded it. Okay, but we're not going to blame people, but that's sort of where we're at the foundation. And it's work, right? This is what we pay defense contractors to do, is to provide us programmers and the people around them basically to do all this. And this is the labor that it takes to get everything going in. So there's a lot of different ways of looking at language that programmers are using to talk to the machines. I like this chart because it's basically showing us human readability. How easy is it for the human, me and you, to some of us, a human, how easy is it for us to read the code? So I'm not talking about the machine binary already compiled. I'm talking about the code that's being written by the programmer. So there's a couple that are very easy to understand if you was to look at it. So Perl, Python, Shell, JavaScript. Okay, these are all fairly easy to read. Execution speed of that capability is pretty low. When you start looking at the speed at which the machine's able to execute the program, there's a downside to this, and so as we start looking through the different type of coding and the different stuff out there, the highest speed program that basically can exist is binary code, and that was a quiz question. A lot of people put the assembly language, which I would have agreed with a couple years ago, but the binary code is read by the hardware, not by the human. It's not readable at all. I've actually programmed an assembly code before, and so there is some degree of readability, but yeah. So here's just it gives you an idea of where the speed at which the program is able to execute versus can we actually inspect the code and see what the heck it's doing. So just an FYI on that. Of the top 10 programming languages that programmers use as they go through here, nothing really special about this. The DoD, I can't find anything today, is not prescriptive on what language to use. In 1987, the DoD said everybody should write code in ADA. ADA was the name of the language in 1987. I don't see that on this list. There's a problem when you are prescriptive in the language in which the programmers use, is it goes away really fast, right? They're all the time expanding the coding infrastructure. So Fortran's gone, Ada's gone, COBOL is gone, and so you really have to look at who today is learning a language in school. So they're learning C++, they're learning Python, they're learning JavaScript, all that type of languages. So do we care? Ultimately, maybe not. So we're not prescriptive. What we're prescriptive on is what we're going to be talking about in this class, and that is the process that we're going through. So that's really an important part to put here. So this is just for your giggles and information of how long ago these languages were developed. I never even heard of Swift, so here's what it is. So what is software? We talked about what is programming, and what is software? What is software? That was a question.
Software would be the interface that allows us to interact with the machine, and then it converts what we want into a computer language for the machine to then understand.
Yeah, exactly. Software is a set of instructions that tells the computer what to do, right? I hit my my left turn blinker signal, and there's a relay that's talking to the computer, basically turns my signal lights on, right? It's that software tells the computer what to do with some sort of input. It's the stuff that makes the machines and most of the military equipment run these days, right? It's everything that is around us is software driven. There are some mechanical stuff. I was thinking of my time on the Ronald Reagan. I told the ship's captain, I said, hey, you know, there's not a space on this ship that I don't have a piece of software or a piece of equipment in. And he was actually taken aback by that a little bit. And I was like, yeah, from the bow of the ship to the stern of the ship, I have telephones everywhere, which is software driven, ICANNs at the time. He said, well, what about the reactor compartment? I said, I don't own anything in the reactor compartment. The reactor officer owns that, but there are mechanical things in the reactor compartment just as fail-safe because they don't believe in software, you know, when you get to that extreme. So as we talked about, it's a engineer, it's a coder, basically writing a set of commands in a special language that we just talked about that the computers understands. So what is software development? It's effort needed to produce those instructions, the program to tell the computers what to do. It can be waterfall or agile. It can be monolithic or all of the above. What would you pick here if this was the quiz time?
D.
Would somebody say D?
D is in Delta.
Anyone else think it's not D? I don't think it's D. Now, there we go. Someone is, yeah. Waterfall or agile is the process, isn't it? Are we gonna develop in an iterative way, right? It's not software development. It's the process of software development. So it's like, well, maybe it can be monolithic. We're going to talk about monolithic, and that's the architecture of the software, all of the above. You know, I thought about this one. I was like, you know, I could sort of, software development is the whole process, right? It's the process in which we're going through. I liked A. Actually, that would be the one that I would have picked, but I would probably give credit for D, sorry, all the above. What do you think? So these are the things we're talking about. You haven't done monolithic, so we're a little bit off sequence. I want to do this first, so we'll talk about monolithic. Modern software development is faster and more iterative. There's a reason that it's faster, because it's the initial capability in which we're able to give to the hands of the user and start seeing working software faster, right? All those manifesto things that we talked about in Agile. I would suppose, and there's mixed comment in the literature and in the research that you could do on this. Which one is ultimately faster in delivering the full capability that the warfighter needs? Waterfall or agile? There are many that say they're probably pretty close to the same speed if you look at getting the entire capability into the hands of the user. Where agile, there's a lot of benefits to agile. You get working software in their hands quicker. They can give you rudder direction, you know, do this, do that. I don't like that. Where waterfall is like, you sort of got to know it all and you're going to deliver the software. So that's the goodness of it. But many basically say that if I know all the requirements and I do an agile methodology and I do a waterfall methodology, they're probably going to get to the same place ultimately. It's just simply how good is it when you get there. Okay, so which one's faster? For full capability, it's probably a tie. Which one is a better quality software? Which one is the user more happy about? Which one has less defects? Probably the agile. But from a total speed, it's probably the same. From a total cost, it's pretty much close. So there are those, and I'm telling you, there are those that say, if we're going to do agile, it should be cheaper. So that way we should get savings if we do agile. I was like, well, maybe a little bit cheaper because we don't have the defects. Maybe we don't have to do, start again. If you're going down a waterfall methodology and you figure out that you didn't get it right or something's wrong, you have to go all the way back into the design. Where agile is able to grab and understand very quickly and maneuver, so you don't have a lot of technical debt. I'll give that word to you. Technical debt. If you don't have a lot of defects that are hidden, you're able to expose it quicker, so you don't have to redo so much so often. Maybe. From a cost perspective, I would not take any budget advantage in agile. So we talked a little bit and thought about and we'll talk in the future about cost estimating. How do we do cost estimating in agile? The worst thing you could do is say, well, this is what I think it would cost in waterfall, and then let's take a 25% cut because agile must be so much better, so we don't need all that money. So I'm just sort of giving you what's going on today that I'm hearing is agile is no faster than waterfall as far as delivering the full capability. It's just that it's better and more iterative, and we can get things in their hands a lot faster initially. And it's probably not a lot of cost savings. Does anybody not agree with what I said? You can, this is, everybody understand what I'm talking about? Don't take savings in schedule and don't take savings in cost, because those are these people that have this mindset that it must be cheaper and it must deliver faster. They're a little bit sort of, but they haven't grasped the entire part of it. Okay. When I say modern, then something must have changed. It could suggest there's something before today, some pre-modern ancient phase of software development and some sort of history. I used to have this class do a little bit of history review there's a document from 1987. It's called Military Software, and you can do a Google search on it. You can find it, you can read it if you wanted to. And it really talks about we need to change the way we do our software for our weapon systems. 1987, and they were suggesting a more iterative versus a waterfall.
Okay.
Modern software, you can hear it all the time, and basically is like, well, what do you mean by modern software? In our terms, the core principles of software development really haven't changed very much, but our description of what it is we're doing has changed. So the description of doing agile, those words of iterative and coming up with a methodology is about 20 some years old, 24 years old. As we sort of move next week and talking about DevSecOps for a considerable amount of time, that is another way to think about modern development of including security and including a feedback loop. So it's more of a process thing. So it's important when we say, well, we're modern software development, what exactly are we talking about? And it's going to change, right? It seems like every 10 years there's some sort of change. What's on the horizon? Is it going to be, some sort of AI agent that basically is now employed to do the programming of this? Is there some other way that we can do it? Who knows? But I'm not a future predictor, but I can tell you where we've been. Maybe it would have been better to do the monolith at first, but anyway. So modern approaches that we're looking at is DevSecOps, and we're going to be looking at the architectures of a modern architectures. Like, if you're not going to do monolithic architectures, what is it that you're going to do? So we'll talk about that into some details and the goodness and the illities of that. So we're basically looking at a capability that allows our development teams, our software development teams, to build software faster and more iteratively, right? This is important that we understand this. Working software in the hands of the user versus extensive documentation, right? That's one of the key features of this. So we don't have to wait months to get this capability in their hands, and we can get capability to them iteratively as time goes on. We can add new things out there, and we have to have an architecture that supports that. We're going to talk about containers and moving away from monolithic to more of a containerized system. And basically there's a lot of advantages to doing this because you can deliver capability in little chunks, and you don't have to worry about the entire program getting recompiled as it goes through here. As we start talking about containers and microservices and stuff, there's a lot of advantages to this, and we're going to talk about this in spades, but I'm sort of laying the ground seeds, the groundwork and planting the seeds here of what it is that we're actually talking about. We're talking about capability that when I'm developing it, whatever the programmer is writing the code and the software development team is using, it should be able to run on their systems just like it's going to run on our systems on our ships or wherever it needs to go. And we'll talk a little bit about data centers and virtual machines, all this stuff that is probably in your mindset. Our infrastructure has evolved. A lot of folks talked about the cloud, and one of the 10 commandments said, do hardware modernization every 2 to 3 years, I think is sort of what it says. Like it should be almost like a commodity. Some people said, well, you don't really need that if you're going to the cloud. It's like the Google notebook or whatever, right? There's nothing really on that besides just keyboard and screen, and it communicates back and forth via the cloud. Some of that's good for infrastructure for the DoD. If you're talking about a warfare system, my assertion is it's good to connect to the cloud when you can. There's value to that, but our warfighting systems are going to be able to be disconnected and operate in a day without space. And maybe you've heard that term, or in a contested environment. Do not want to rely on satellites. That's your first thing that's going to go in a conflict.
Hey, Professor.
Yeah.
So does having a microservices architecture, that doesn't necessarily mean that you're on like a cloud-based server then, right?
Yes.
Okay, thanks.
So if you, well, what is the cloud? I mean, I don't talk a lot about the cloud because that's really outside the scope of the class. But on board a ship, on an aircraft carrier or any ship that's running CANES, the Consolidated Float Network Enterprise System, the IT system, it is a cloud-based architecture. It's a local cloud, right? They're able to share and communicate and do all the things that they need to do from a cloud perspective. When we talk about cloud and software development, we're talking about using the cloud for software development. So I don't need to buy racks of equipment. I don't need to buy the software. I don't need to have an IT team basically setting up and managing this. I can go to the cloud. It's called Platform One for the DoD. And I can do all my development in the cloud and be connected. So it's developing software. It's basically a cost savings event, and it's also a standardization event. Everybody's basically in the DoD using some sort of cloud-based architecture that's approved by the DoD. So that's sort of where I'll leave it there from a acquisition perspective. Buying services, buying cloud services. That's what's the name of the cloud service thing that just got approved?
JWCC.
Yeah, I like Jedi better, but anyway, we had it JWCC.
Yes. And that
Yeah,
was a
one-
combination for both AWS and Microsoft. So it was sort of previously AWS kind of led the Jedi cause, but Microsoft and AWS, along with some other services, combined those efforts, that larger contract vehicle.
Yeah, that was an ugly acquisition process and ended very poorly. And ultimately they said, well, what is it that we want? We just want to have access to and contracts for, cloud services. So why do we need to pick one? Let's pick them all. So I think that's sort of what they came out in my Washington student there. She knows it all. So Zoom, it runs on the infrastructure. The cloud, as we've chatted about, instead of having, I remember, data center consolidation. We had all these data centers that, basically we're doing all this compute on, all the buildings had one, and they're like, no, we need to consolidate to save money was really their main quest. So I remember this going on and how much money we're going to save. And then the cloud basically stood up with AWS and other certified cloud providers and are like, why are we maintaining a data center for? So that's what I was talking about, the architecture moving and technology moving, and whatever we thought we were going to be using sometimes becomes obsolete in 10, 15 years. So it is a challenge sort of stay up with it, and what are you doing? As we start talking about architectures, software architectures, one of the big ones when I was running a program in 2005 was service-oriented architecture. The SOA was the big buzzword, and then ultimately that got replaced by something else, the cloud. So renting and the power of the cloud, especially when we start talking about software factories and not having to buy the software factory over and over, this is a big deal. And having our contractors use the government cloud and our software factory is a good thing, right? They're able to use that. If they have their own software development factory and stuff, then we just have to look at it from a compliance perspective, make sure all the tools are compliant, and making sure that we don't induce any vulnerabilities into our code. That's a big deal. Software factories, we're starting to use this word a little bit. It's like, well, what's a software factory? It's a software factory, if I was trying to define it, is the place in which we develop the programmers develop the code. It's a place in which we run all of our automated tests. It's a place in which our security professionals are involved with the programmers, and the operators are sort of involved. It's sort of our view of software factories is sort of DevSecOps. Is sort of, when I say one or the other, they're synonymous. So this is sort of where we're going. The ability to start a new software program, as far as doing it, I don't have to build the infrastructure. I don't have to do any of this stuff. As long as I have my connection to the cloud and I'm able to turn this on fairly quickly, then it's sort of there. I don't have to buy licensing. I don't have to buy any of this other stuff. So that's sort of the beauty of it. We're sort of making our software factory in the DoD in particularly more of a service at that layer. And so this is a really big deal for us in the DoD to have the work done by leadership to say, hey, here's your tools. This is how you're supposed to do it. Follow this guidance, and you should sort of be okay when you go through developing your software. So this is sort of where we're at. It's sort of an analogy of a pastry chef baking cupcakes, right? We need to make sure we're using the best tools, all those tools that are certified. And we'll talk tools in this class. So what are the software tools that we're going to be using to develop the software to make sure that the code is secured and we don't induce any vulnerabilities through a supply chain attack. But this is sort of what we're thinking about. And we need the infrastructure, best infrastructure we can have available. We don't want to spend a tremendous amount of time in the startup process, just having everything sort of laid up. So using automation, I mean, could I use a manual whisk to do the eggs and to do everything? Sure, but why wouldn't I automate as much as I can in doing this? So going from maybe wooden spoons to a blender, and maybe going to vice baking, trying to cook over a fire. Maybe I have a set in a kitchen. I don't know, is that a KitchenAid? Yeah, it looks sort of weird, but that's sort of what we're talking about. Got to have the right tools for the right job, and I shouldn't have to recreate this every time, trying to figure out every time I want to bake a cupcake, you know, should I use a wood fire outside or should I use an oven? Same thing for the ingredients. If we think about the ingredients as the tools that sort of sit there, you know, I'm going to go and I'm going to buy this stuff. I'm going to go get the license. I'm not going to develop the tools when it already exists somewhere else. So, you know, making sure that, you know, I just want the eggs. I don't need the chickens in this case. They start talking about server rooms. This is sort of the old way of thinking. I'm going to have my servers, I'm going to have my data centers local. As we move to the cloud, I don't have any of this if I'm truly doing a cloud software factory. So this is sort of a skip there. So all of this convenience, all of this stuff that's already been done for us, we just really need to fine tune it. And making sure we have all the tools that we need and it sort of fits our application that we're developing, our software application from this perspective. So cloud services sort of do this. It is the raw materials that the developers need to run and power their application. So it is a big deal not having to reproduce all the infrastructure of the software factory. I just need to go and use it. And when we get to talking about platform one, and everyone that's using these cloud services and the documents and the processes, then we started getting a standardization of how we develop software for the DoD. So our software development process is changing and modernizing. The methodologies and our culture is improving. There's more people that understand this and our ability to do this. 2 years ago, SecNav put out guidance on using the adaptive acquisition framework. One of those was for software. So they said, hey, if you're going to go do this, hey, tell us that you're going to develop software this way using the software pathway. And there's 5 metrics that we need reported. Besides that, it's like, yeah, do it the best that you can possibly do it. I think that's sort of it. So DevSecOps is a big shift in the way that we develop software. And it's basically, has anybody seen this DevSecOps infinity circle before? So what about it? What's the big deal about DevSecOps and this infinity circle?
It kind of goes back to what we talked about with software development with modern. It's never done. It's iterative, and the process just is a continuous cycle to continually improve on the product and ensure that it is secure.
I agree on that. I could do that using an agile methodology. What about DevSecOps? What about this? What are they trying to portray in this? That is continuous and it's never ending. I got that, but what exactly are they talking about?
Hey, Professor Randy Harmeyer here. Can you hear me? Over. Okay, good. I'm on the phone. Is it? I'm not a software developer. I would guess that perhaps that a program in DevSecOps is in just about every one of those stages simultaneously. Is that a fair way to get after this? Over.
Yeah, it is weird when you look at it because it seems like you're working on everything at the same time. And it does look really weird. And we'll chat a little bit about what that looks like. But yes, Matthew?
Yeah, I think someone put it in the chat, but I think it's going back to, if you look at the phases 1 through 4, it's that shifting of security and development to the left of the process, right? So it's earliest stages of development in the planning and pre-production phase, how much you have to understand the problem before you just start trying to write code for the hardware, right? You just usually kind of, that's what happens in your lap, right? And so that's what makes, I think, it a little bit different from agile, but very, very closely intertwined for sure. Over.
Yes, and I think that that's an important part of it. In traditional methodology like waterfall, when we're done, we send it to the testers. We try to do compliance with some sort of RMF architecture, blah blah blah. But we're testing it. We're testing it out, and testing happens to the right of the process. And basically in DevSecOps, what they want to do is take these tester teams and these security experts, software security people, cybersecurity experts, and start educating the developers, the programmers of what is the best methodology to use. What does secure look like? And so there's a lot of education, there's a lot of collaboration, and there's a lot of testing that happens. Automated testing and stuff happens on the left side of this. So things as they're building the software, they're using best practices that have been given to them by the cyber folks, but they're also doing testing of the code continuously. Every time it gets a programmer basically develops some code that day, they put it into the repository in the big bank in the sky, and overnight it tries to integrate it and tries to do some testing to make sure that everything looks good as we're building it up. So test left, that's what they're talking about. Bring testers to and our testing of the software in pre-production. Make sure that we're delivering good code and secure code, following best practices, and also doing automated tests. So that's pretty awesome, right? What about this right side of this circle? What are they trying to talk about over here? The right side of the infinity circle. And it's okay, we're gonna talk about this in spades, but just to give sort of a primer to what we're gonna be talking about next week and week 4 and 5. What's the right side? Joe?
I would just say where the left side was the drawing board. The right side is more so like putting it on the assembly line, figuratively speaking, just seeing that, in practice for the first time. And yeah, basically
Okay. It's the deployment of stuff. It's actually giving it to the users. If we say we're going to give them software and we're going to give it to them iteratively, it's sort of like this process, right? I'm producing the software, I'm testing the software, I basically release that capability of that software that I've been giving them something, and now I'm adding stuff to it. I'm deploying it, I've tested it, I'm doing all this other stuff that's in there, I'm monitoring the software. So no longer am I just giving them the software and saying, good luck, I hope that thing works for you. We're now connecting the two systems together via telemetry, being some other method to where the machines, we're monitoring the software as it's being used by the user, right? Most of these devices, you have a smartphone, something like this, they ask you in the user agreement, are you okay with us monitoring the software to make sure it's okay, right? That's that side of it, right? And when a piece of code or something's not working, it calls home. I don't know what it's doing, but it's calling home and saying, hey, we got something going on here. You may need to go fix on this. So this is, and also from a cyber event, as you have your software out there and something nefarious is happening, it calls home and says something's wrong here. So there's a cyber aspect to this too. And I'm literally telling you that we plan on ships at sea running like the Aegis combat system, it's going to be every now and then it's going to call home and report back to the forge, to the software factory, how that software is doing. I'm telling you that today. In 2012, I was working with PMW 120, which is the Battle Space Awareness C4I folks, and the captain at the time, Captain Heller, he said, "I don't understand why we can't monitor our software at sea. Why can't we not get automated feedback and stuff?" And it was a process. We did not want our ships to be recalling home. We wanted to have full control of what was going on the ship. You know, if you go into some sort of MCON, you know, basically secure your transmissions, blah, blah, blah. It's like, well, that's still all there, but you just you had a really stupid, archaic process in which you didn't want to have software calling home and reporting on itself. That's changed with DevSecOps. This is the principle of it. If you can't do this right-hand side, then you're not doing DevSecOps. You're doing something else. And we'll chat about that as it goes through. And testing, quality assurance, all this is built into it as we're building the code as it goes through. When we think about the testers in the old day, basically they sat in some sort of room. They basically said, "I'm waiting for the code, it's coming." They weren't communicating with each other. They weren't sharing knowledge of what was going on. We still have that today. We got this operational test community. And said, well, you know, if it's a major program, we need to have the operational testers do suitable and effective. Well, how do we shift them that direction? And that's a big problem that they're experiencing today. So when I say modern software, when I say you know, this is sort of what we're going to be trying to understand and why it gives us speed in delivery. That's really the main thrust of this course. So we're going to be talking about DevSecOps. We're going to talk about architectures next. We're going to take a break. Actually, we're going to take a 10-minute break to the top of the hour. So if you want to go observe colors at your location, if that's on the West Coast, if not, I'll see you in 10 minutes and we'll talk about the next monolith. So let's talk about monolith and monolithic software architecture. What's from the homework that you did and the readings that you did leading up to this, what's your thought about what a monolith is from a software perspective?
Sort of how the title applies. I mean, mono as in being one, so one large package all tied together to deliver just you know, as is. And
yeah, it's a integrated, connected piece of software that is it's tested as one, it's built as one, and it's deployed as one. So it goes through the entire cycle as one capability to build whatever it is that you need to do, tightly integrated, tightly coupled. And if you need to update it, then you need to make sure that you haven't broke the monolith and caused, you know, secondary problems. Also, deploying the monolith requires a complete movement of that software from one point to another, whether it's on tape, whether it's on a DVD, whether it's over the air. You're getting the whole kabang, everything that is needed to run, you're getting it all at once. So in itself, just thinking about that, how do I add new capability? I have to redeploy the monolith. In a constrained, yeah, AOL, in a constrained environment, especially ships at sea, at the tactical edge, or Marines at the tactical edge, or any of our armed services at the tactical edge, if we need to give them an enhanced capability, or there's a cyber exploit that's going on, I have to be able to deploy at the speed of relevance. Got to be able to do that, and you cannot do it with a monolith. That makes sense? So why would we ever build software this way? David, go ahead, sorry.
So for me, I'm kind of been answering your question. So many of the different things that you just gave are the same characteristics as buying hardware in the DoD for me. So the reason why we did it, I mean, this is the buy one thing, make it work, add all of the ilities, make sure that it has the full logistics and cyber, and buy it with a plan to use it for the next 30, 50 years or something like that. So, why do it? Well, it's like the way that we've always done it. And if somebody was always buying hardware and suddenly software is a thing, it's like the way that we would immediately start buying software without thinking of best practices and commercial industry and all that kind of stuff.
Oh, I agree. It was that was reason the 10 Commandment talking about hardware. Yeah, we would buy the most exquisite hardware we possibly could, almost bleeding edge technology, because we knew that piece of hardware was going to be out there for the next 15 years. And when you look at Moore's law of computational power and speed and everything, you wouldn't be using a computer from 1990. All right, the processing speed, the memory, the architecture of the hardware itself, the compute infrastructure has changed dramatically, but here we are. And a lot of it is the same problem we have with software. Is the monolith? You basically when we talk about the aegis problem, it really becomes evident about how having coupled hardware and software causes big problems when you're trying to update the software. That we're confined by the hardware infrastructure. So decoupling software and hardware is really important, and then changing the architecture of the software, the way we develop it from a monolith to something else, is really the intent of this class. So hopefully we'll get a good idea on this, and we can talk about hardware too a little bit because that's important. All right. So what is a monolithic architecture? Here's an example. It's a commercial IT example. And it basically is trying to demonstrate that it's all in one. Basically, it says everything's connected. And so this is a example of a service provided by the application. Just think of like a banking system or going to an ATM machine. That basically you're trying to put in your code. It has to go back. It has to develop it has developed its business logic. It has a data access layer, and ultimately goes back to the database to try to figure out whether you have money or not to give you that. So so this is it's like a big container of stuff. All the processes are built in the monolith. It has everything it needs in order to operate. It's not going out and asking another app for information. It's all sort of built in there as it goes through. It's tightly coupled. It's tested as one, and each component fully depends on the other components. And that's just how the monolith is sort of built. So if we want to change the code, if we want to change something in the data access layer or in the business logic or even the client user interface, you got to recompile and test the entire thing to make sure that you haven't done something that causes it to break. In a monolith, everything has to be there for it to work. If they got something wrong in the data access layer and there's some sort of bug in there, then the monolith does not work. There's nothing else you can do. So this is what we're talking about. If I start giving you the characteristics of a monolithic software architecture, it is a single executable file. It is compiled and it has a single executable file. It basically there's thing that basically you type in this particular code .exe and it executes the monolith. It starts it up. It's all deployed as a single file. All components are bundled together. Tight coupling. So all of the components within the monolith are highly interconnected and they depend on each other in order to work. And if you change one of the components in the monolith, you want to go adjust something, you may have to modify other parts of the monolith if you're actually aware of how these things are designed and connected to each other. So it becomes pretty sketchy when you think about, we've had this software for 10 years and now we want to update it. It's like, who's been around? How did they actually couple these systems together? And it may not be the same developer who coded it originally, the monolith, who's working on it now. So you can see that it could cause a lot of challenges in there. It is a monolithic deployment. The entire application is deployed as a single unit. And if I update or I change the code, I have to redeploy it as a monolith. It's interesting when we start looking at the Aegis system. Did anybody remember or see the size of the software that the Aegis combat system actually is a monolith? How big it is? Go ahead.
Yeah, it's the size of a fridge.
Oh, that's the hardware. I'm talking software.
Okay.
Go ahead, Elaine.
Yeah, it's a huge file size, and not to mention the fact that the installs, like, they take months in order to do full installations. And you got rel servers and you've got like basically an entire software load that has to be planned out and staked in an avail. And if you have any interruption in that time, you got to start over from scratch.
Yeah, the last code, the number of lines of code. Now, I'm going to tell you that I'm going to give you a number, and it should mean nothing to you. If I say 9 million lines of code, somebody said 14. I think the last codes file I seen was 9 million lines of code. That the program 9 million lines that a programmer team basically coded to make the Aegis combat system work. When we talk about estimating, cost estimating and everything, sometimes they use software lines of code as an analogy to say, well, if it's 9 million lines of code, then it probably is going to cost this to do. I'm going to tell you that's a bad way of doing it. But just from a number perspective, 9 million lines of code is a lot that you can get wrong. And redeploying that is, from a file size perspective, I don't know how many gigabytes it is, but it is it's something you would not want to do on a ship that is at sea for sure. There's some advantages to a monolith and sort of how we got here in our weapon systems. High performance. The monolith architecture can provide high performance, and because the way that the compute infrastructure communicates with the software, it does. There's some special magic that happens between it. That's all I want to say. I mean, we can talk kernels and we can talk user level processes, but it's really fast. And if you think back, and when we talk about the Aegis program, when it's first started in the 70s, 1970s, we wanted it to do spectacular things and do it fast on really old, slow computers. So doing a monolith sort of made sense because you can get high performance out of it. Not that they had any choice, but that's sort of how it sort of worked out, that they basically were able to get the spectacular capabilities using pretty archaic. It's pretty simple, right? The design of the architecture is a little bit simple. You can sort of where everything is going, all the binary codes moving back and forth, and it makes it easier to develop, and it makes it easy to test, and it makes it fairly easy to maintain. It's pretty straightforward. Broad hardware support. It means that for the hardware that it was designed to work on, it sort of works on it. There's other doors. My dog's scratching at one door, and there's a door open on the other side. Crazy. So for whatever they were designed to run on, it basically runs on that hardware. So it's sort of connected. from a hardware platform perspective, from a hardware perspective. The monolith has low overhead, meaning that it doesn't require a lot of system resources. Sort of comes back to the high performance part of it. So if I have a resource constrained environment, like a hardware constrained environment, monolith sort of makes sense. I can get high performance out of it. I can do low overhead. And so, you know, on like embedded software on a cruise missile, it's probably going to be a monolith, right? Because you have limited compute infrastructure on a cruise missile, and it takes pretty low overhead. So yeah, I'm probably going to do a monolithic architecture simply because that's sort of what I need on a Tomahawk that's going in, right? I don't need containers. I don't need to update the software as it's in flight. So fairly straightforward on that. Easy to access the hardware resources. All the code runs in a particular space on the hardware. And I know how everything connects, the graphic cards, sound cards, everything is there, and it's all prescriptive. So these are some advantages in there. Fast system calls, it basically, there's a low overhead. So when it's trying to communicate with the hardware and other pieces of the hardware, it happens pretty fast. Once again, if you're in a hardware restricted environment, this makes a lot of sense. And monoliths are really good for like general operating systems. They really are good for that. So it basically I get a high degree of performance with a low overhead. So some advantages of monoliths, and I'm not saying don't do monoliths. It just really depends on where it is. If it's an embedded piece of software on a weapon system, it's probably going to be a monolith. Okay, you guys tracking on that? Disadvantages of a monolith. These can be pretty large and complex applications. They are all connected. It's sort of like spaghetti code once you get in there. Multiple components are combined into a single large application. You have to test it as a single large application. It has a large code base, like 9 million lines of code. And over time, it can be very difficult to manage, or even to try to fix something that's inside the code. That's really an important part. It's slow to develop new capabilities. If I have to update one part of the software within the monolith, I may have to recompile it. I may have to test it again. I have to make sure I didn't break anything as we look at this. So this is time consuming, it's resource consuming, and it limits any agility or speed to get the capability into the hands of the warfighter. So one of the things that when we talk about why does it take so long to get Aegis new capabilities into the hands of the warfighter, 6+ years, this right here, a monolith is slow to develop, it's slow to test, it's slow to deploy. It just simply it is something that if you want to modernize an architecture, it is you have to understand where you came from, because we're not coming from scratch on this. It's unscalable, and this is talks about if I have a monolith application and I want to basically have another system use it, I have to bring up another version of the monolith. And so I have basically 2 monoliths running. If I want to have 3, I have to call up another version of the monolith. So it doesn't scale well from a business perspective, because it's all combined. And I'll show you that when we start talking about containers and microservices, of how that actually can scale and doesn't require you to bring up the entire program. You can just bring up the application. Unreliable. If there's a problem in the monolith, if one of the services in the monolith is causing a problem, it affects everything that's connected to it. And all service applications are connected to each other. So this happens sometimes. From personal experience, I can tell you when ship self-defense system was put onto the Tarawa back in 2000. In 1999, when they got the new version of software, we had a major problem with that monolithic software that every 2 or 3 days I would have to do a cold reboot of the entire system because there was some component within there that was causing a memory leak or something. But when I got it as the user, then I'm stuck with it, and it was definitely unreliable. Those are war stories. Drawbacks of the architecture: it can be difficult to understand. The code may be extensive. It can be difficult for new developers to understand what is going on and to modify the code. And this gives us this vendor lock, right? We've had vendor lock with Lockheed Martin and Raytheon in our combat systems forever, because they're the only ones that have the expertise and the knowledge to continue to maintain and update the software, right? There is no competition. We are locked in there. So monoliths, we're sort of like, yeah, we need the OEM, the original developer of this, to be there in order to do the stuff that needs to be changed. As requirements evolve and become more complex, it becomes difficult to implement in a monolith. If I make a change to one area, I'm not 100% sure that I'm not going to affect the quality of the code in another area, and it may affect the entire monolith as an operation. Developer must compile the entire code base and redeploy the full application. So if I need to make a change to something, you know, there's a deficiency that basically a Pry1 deficiency means got to go fix this. I have to go back through the entire test cycle, make sure I didn't break something else, I have to redeploy it. It's a big deal. Hopefully just starting to get the feeling that this is probably not where we want to be for some of our weapon systems, combat systems. The size of the monolith can increase the startup time and add to delays. Many times in a monolith, and especially if it's a multi-rack piece of hardware equipment, you have to do it sequentially. You have to do this, and then you have to do that, and you have to do this, and you have to do that. For the Tarawa back in 1999, it took them almost 4 hours to reinstantiate the ship's self-defense system. Maybe 3 hours on a good day. And it's basically you're waiting because it has to load in a particular sequence. So startup time is not the best. makes you sort of wonder. So I'm on a ship, I'm on deployment, I'm out there at the tactical edge, and the power goes out on the ship. I got a little bit of backup power. They give you ups. Basically, the ups, the universal power system. I don't know what the ups stands for, but it's the battery that allows me to do a smart shutdown, is what it's meant for. It's not for me to continue to operate the system. It's to shut down smartly, and hopefully they get the power restored before things go really bad. But having your combat system, uninterrupted power system. Thank you. Yes. So this is a big deal. The specific order that I talked about because of resource contention, power supply, reliability of the monolith. If you have a bug in any one of the components, it can bring down the entire application. Think about cyber. If I have a cyber intrusion, they're able to get into a particular part of the monolith and insert some sort of code or basically do a cyber exploit. The entire system is compromised. So this is the reason I have to have very strong defensive external boundary, like gate guards and cyber protection to try to keep people out. When we talk about cyber in this class, we'll talk about why monoliths are really poor at defending itself, because once you're in, you got everything. You can do whatever you want inside. So this is a big deal. We'll talk about why monoliths are less secure than something else. Monoliths are pretty good for something that is simple and lightweight applications like embedded systems and a cruise missile or some sort of weapon system that has low hardware compute resources and stuff. So yeah, do monoliths, not a big deal. And usually there's not a tremendous amount of code that's in there too as you're going through. So for complex applications, that basically I expect to change over time and scale it based on user need and what's going on in the environment. Monolith architectures is not really suitable for this. Sort of like this. This is a combat systems. I don't think it's Aegis. It could be. I don't know when the Navy was wearing black ties. It was way before my time. In the military, but we would do a lot of this testing and making sure everything worked in this combat system. So we're going to sort of make this shift now to what's going on in our Aegis combat weapons system. Just as an example, this exists in many areas. We still have monolithic architectures, and the question is, what do we need to do to change from monolithic to modern architecture? If we think monolith is not responsive and not able to be changed quickly at the tactical edge. Does it start making sense a little bit? We say speed to capability. We need to add capability at the tactical edge. If you've got a monolith, it doesn't happen. Zero go non-start, ain't happening. So if you want to do it, then you need to look at your architecture first. So what does a combat system do? What is it that it actually functionalizes? It's a centralized automated command and control weapons control system that controls weapons, and it's a total weapon system from detection to kill. That's primarily what Aegis is, and all of our combat systems on our ships. Since this is a Navy class, we'll talk about this. There's other services that have the same type of system. It was designed around the Spy-1 radar. This is a digitally steered, software controlled radar system. It instead of spinning a radar that goes roundy, it basically is the phased array. Basically, it sets on the side of the ship and it steers things digitally. Awesome stuff, very awesome technology, and many capabilities besides just detecting aircraft or ships. But primarily what it is a high power radar that can perform. I can search for things, I can track things, I can designate a missile to fire upon it. I can do all this simultaneously. And so you can start seeing like, well, this seems sort of resource intensive, right? That you got to be really fast at doing this. And when this started 50 years ago, this was a pretty big deal. So 14 million is actually the right answer. I thought it was 9. I thought I'd seen it somewhere, but 14 million lines of code later. This is sort of where we're at. 50 years of development of this combat system. And the code has been massaged and refactored and upgraded for 50 years. So you can sort of see that there may be some challenges. So from an architectural view, I know this isn't an architectural class, but here's the Aegis weapon system itself. Here's the software that we're talking about. And it's connected to a bunch of stuff like the Tomahawk weapons control system. I worked on this piece of software down here in order to launch the Tomahawk weapon systems through the VLS. So that's, you can see all these other things. It's sort of connected to the sonar system, right? Looking for submarines. So it's a different piece of software running over here, all monoliths, by the way. And so you can see that this is a very integrated set of systems that go in there. So, but from the Aegis weapon system, we're talking about this. The Aegis display system, we're talking about the Spy-1 radar, the connection to command and control and decision and the weapons control system. All this stuff is in that barrier right there, and the connection to the launchers, so the shoot the missile out the other end. So that's sort of where it sits. Yuck 43 computer is sort of the computer we're using. It was first delivered in 1984. And we've built a lot of these Yuck 43s, and we've tried to modernize them. These are the size of a refrigerator. If you want to get the if you want to get the size wise, it was built. There was enhancements to the Yuck 43 to go to an open system architecture, and so basically they've been tinkering around with this forever. And right now, the Aegis Combat Systems is using a virtualized version of this. So they're trying to get away from a rack of equipment that is all sort of connected to being able to virtualize it and run it on modern hardware infrastructure. That's not what this class is about, but this is important to understand. They're trying to decouple themselves from a unique piece of hardware. Go ahead, Elaine.
Yes, sir. So, I mean, in addition to virtualizing the Yuck 43, I don't know if there's actually been any development in improving the processing capability that the Yuck 43, because it's even very basic on what it does when it's virtualized, right?
Yeah.
Yeah.
Well, and it's also the monolith. It's still running the monolith program. So that's sort of the two sides of this coin. Is they understand they need to modernize the hardware, but we also need to modernize the architecture of the software to take advantage of the new hardware architecture.
Right. Yeah.
It's a couple things. Okay. So this is their slides. PEO IWS came 2 years ago and briefed us at NPS. Last year they came again and with an update. And this is the risk that they identified that we live today with the Aegis combat system. Changes to the architecture across variants to accommodate different hardware configurations drives complexity because the software is connected to the hardware version. And so it starts driving all these baselines. They call them baselines of what code they can have with what particular group of hardware that it's actually set up. User's not involved in this a lot. Usually the user is the people that are sitting on the deck plate when they bring install the new baseline. And at that point is usually the first time that users are actually looking at this and wondering what the hell is this. And any type of feedback basically says, okay, we'll write that down, and maybe 6 years or 8 years from now, maybe you'll see it, right? It's like, why bother? And so we'll talk about this, about, it's the challenges when they discover problems on the deck plate when they're installing this. In order to fix it, they have to go back and patch it or recompile the code. And once you do that, you just open it up a big can of worms. So that's usually a challenge. In the Aegis community, they have land-based test sites. So there's a lot of resource contention. We only have a few of those. I'll show you the pictures of those. And so we're competing with different development environments. The hardware uniqueness drives singular labs that are only used for that. And while other ones are idle, they're overtasked, blah, 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 blah. Right, it's just like a ball of yarn here. If we discover a deficiency once we've installed it and we're at sea with it, I have limited ability to change the software. What's CSCP? Combat System Certification Program? Is that what that is? Good. If you don't know, Elaine sort of lives this as her nighttime job on this, so that's the reason that I have her here to keep me straight. So my ability to proliferate capability is connected to the hardware being different, the software being different because it has to be connected to the hardware, blah, blah, blah. So this is disaster, big risk. Right? If you If you want to deliver capability at the speed of relevance, it ain't this program, right? And they said, if that is our call, then we need to make a fundamental change in what we're doing. So that's what we're going to chat about. So the goal of the Aegis combat system change is to be able to proliferate capability while reducing risk on the waterfront through application of modern hardware insertion, software practices, architectures, test and automation, and efficient use of test sites, right? That's where we're going here. So that's the reason I had to talk about, you know, agile. That's the reason we needed to talk about modern methodologies and architecture. So that's sort of where we're at. So this is where they're at. And so the baseline performance status quo, the way that they seen themselves 2 years ago was only 10% of the fleet can receive the latest capability every year. And I asked the question, why? Why is this? Why can only 10% of the fleet receive the latest capability? It has to do with how long it takes to develop the software, how long it takes to modernize and design new hardware, and also when the ships are available. The way that this sort of plays out is if you get a new baseline of the software and the hardware, it has to be a C&O availability. And so that means that you're going to be in a dry dock, or you're going to be tied to the pier for extended amount of time. And that's when they come in, and that's the only time they can update the software and the hardware is during those availabilities. And those are limited. It's like maybe back in the past, it was what, every 3 or 4 years, maybe a ship goes into an availability, a C&O availability, that they have to do major new work. Maybe it's even longer than that. We do pier side availabilities, can't do it during a pier side because of the hardware needs to cut a hole in the side of the ship so you can put the hardware in. Crazy. So they start looking at themselves and are like, well, look at that. So every year, only 10% of the fleet can get the new capability. How many years does it take to get all the ships on the new capability at 10%? Well, here's a math question. How long does it take for the fleet to receive the latest capability if you can only do 10% per year?
That'd be 10
10
years.
years.
10 years, yeah. Yeah, there we go. So you can see that this is a big deal. So why does it take 6 years to develop the software? It takes 6 months to test and certify with Delta configuration. It takes 6 months to put new requirements on contract. There are redundant cyber authorizations and efforts. There are weapon system certifications. There's all this stuff. So it's not really about developing the software that takes them so long, even though they're using waterfall methodology. It's everything else that's around it is sort of slowing it down. Diminishing manufacturing sources. Where did you see that at? Was that over here?
It was on the slide we were just on the right hand side. The next slide. Sorry.
Oh, okay. This one?
The right side, third
Right.
bolt down.
Okay, yeah. Yeah, let's talk about hardware. Why not? 10 plus years between hardware upgrades. Who has a phone that's 10 years old?
No one.
No way, Josh. Yeah, well, my wife's like, how come you need an iPhone 15? I said, because I need it. It's faster, the battery life longer, blah, 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 right? And also the camera's better. So I'm taking pictures with mine, and she said, how come your pictures look better than mine? So she started getting hardware envy, and so I had to get her up for Christmas iPhone 15 too. Yeah, big deal. Anybody tracking processors, like commercial processors? What version? I mean, I stopped tracking after a while, right? When we're like what Pentium, and then we're on the i7, blah blah blah. I was just like, whatever, make it go faster and make it consume less power, and make it cheaper. All right, those are sort of, and that's sort of where, you know, hardware sort of goes with it. Big challenge they have is accreditation of a hardware change. It takes them 16 months to basically get configuration change, hardware configuration, right? It's their process. The process is in their way. Now, there's reasons we have these processes. I'm not saying, not disparaging them, but because we learned that, you know, there's problems when you do this. You need to basically go through the certification. You need to make sure you test. They're testing to the right? That's what we're talking about. They're testing on the right end of it. And when they discover a problem, you got to go back through the redesign of blah, 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 right? It's the waterfall methodology in spades. Diminishing manufacturing sources is a big deal when you have old stuff and you're trying to maintain it, right? If you have a circuit card go out, if you have something, then you got to go get a new one of these, unless you did a life of type buy, or you're going to cannibalize another system. This is a big deal, and acquisition logisticians are basically gold in this area to try to make sure that we identify diminishing manufacturing sources and try to come up with alternatives. And here's the install requires a dry dock, hull cuts to put this hardware into the system, and not software, but it's the hardware thing, and major C&O availabilities, right? This is big, 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 big. It costs a lot. So they're not responsive. They're not able to deliver at the speed of relevance, and it's costly to do it this way. And ultimately, it's because we have multiple non-recurring engineering bills. We have different type of hardware. We have different software that has to go in there, the monolith. So it is the development costs for one baseline and one hardware configuration across the entire combat systems baseline. So they just basically say it's really, really stupid to be doing it this way. And they just said, let's do the math of what it's really costing us to do this. It's costing them about 155 million for a baseline. And basically they said there's usually about 7 ships per baseline. So just do the math, do the division here. So the cost per ship in order to get the new baseline on is about $22 million per ship if you just normalize it from a return on an investment type of perspective. And that's only the Aegis side of it. Missile Defense Agency also has a play in this, and there's cost on their side to do the missile defense capability for the ship. They have to be in line with this. So tightly coupled hardware and software prevents affordable capability proliferation. And then from a hardware perspective, there's about 15 ships on the same hardware configuration, and just do the math, and is about $17 million from a hardware perspective. So just add 22 and that, you can start seeing the numbers on here is, you know, 37, 8, 9, $39 million per ship when you start talking about hardware development, hardware procurement, software development, and installation. Big deal. It's like, it's just money, right? We got plenty of that. No big deal. It really has to do with this thing. Low quality and low user satisfaction of this capability. There's no built-in opportunity for fleet feedback. They got their requiremements, the developer has it, and they're doing their thing. That's just the way we done it. We done it like that forever. I did it when I was running software programs. Little or no opportunity for software fixes post-certification. Once it's certified, you can't change the software unless you go back through another certification thing. 10 years of accumulated technical on ship self-defense system and the Aegis technical debt. 10 plus years of accumulated technical debt. It means things that they can't fix. They know that it's broke. It ain't working the way it should, but there's no way for them to get to it. Last year, they didn't show this slide. They didn't show any of the red slides. They just showed the green slides of what they're doing. I just wonder why. I'm still trying to get a firm grasp on this because it really shows a really negative picture on where we're at with our combat system. Almost 7,000 deficiencies on the Aegis baseline. Now, these aren't Pri 1s. Pri 1s means it's not mission capable. These are usually, it's a Pri 2 with a workaround, and we call them Pri 3s or a Pri 4. So there's a lot of those things. We know what's wrong with it, but we just can't get to the point of getting it resolved. When they developed the ship self-defense system, this goes on big deck amphibs. This is on your marine carriers, the marine ships and stuff that we carried Marines back on LPD 17, that type. They use this software. It came from Aegis Core, the common library. So pretty big deal. You know, especially if you have displays that are showing the USSR on the displays. And like, what's a USSR, right? So this is just a artifact of being really broke. All right, what are we going to do about it? Lockheed wins a $1.1 billion contract to design the Navy's integrated combat system. So what they decided to do was instead of having Aegis and instead of having ship self-defense system, if we're going to refactor this and use modern architectures and we're going to develop it a different way, we're going to have one baseline, one software program for everybody. So they're starting to call it the Navy's Integrated Combat System, ICS is sort of the term that they're using. So they're basically Lockheed won this contract. So this is the contractor helping PEO IWS-X basically do this. So they're leading a team of contractors taking the Aegis Combat System code and compiling it and pulling it into a modern compute architecture. They're changing from a monolith to something else. Containers, microservices. That is the modern architecture. I'm saying these words to you because you're going to hear them a lot. You're really going to hear it a lot. But this is the change from the monolith, everything tightly coupled, to splitting this apart and basically making it make sense. This is from their. I didn't make this up. This is coming from the document of the award. They're going to go to microservices, and what that means, instead of the monolith having all the capability intertwined, we're basically going to break it apart into discrete capability. So if I want to be able to track something like an aircraft coming in, I'm going to call up a microservice called AirTrack, and it's going to basically track that. And then if I have another surface track, it calls up the track application, and it does that. And so it's able to scale. And so basically, and if I need to update my air tracker or some sort of capability, let's just say somebody develops a supersonic missile. Maybe I need an air tracker that can track something over the Mach 5, right? There's special capability needs to be developed for this. So that's what we're talking about. They're going to split the monolith into microservices. It's going to take place at the Forge software factory, a government-owned software factory, government-owned software. That's sort of where it goes. Let's watch this video. To make sure that it works. Can you hear the music?
So when Aegis was first designed,
Could you hear her talking? Okay.
its intended mission was to protect the carrier.
Aegis is the single best combat management system known to mankind.
It was to be the shield of the fleet. The Spy-1 radar was designed with the idea of creating kind of a dome or a bubble around the fleet. That radar development was the core of what made it successful.
We've always managed to stay one step ahead and being able to outpace the threats that are facing every day. I think that's something important that we've done from a Aegis heritage and something that we want to continue doing as we move forward.
Because the system is continuously evolving, it forces us all to challenge ourselves and grow. The opportunities for being creative, learning the latest technologies, working with a new business partner, exploring a new open architecture framework are just countless.
So it started out as a single mission, primarily AEW against a near-peer threat, has evolved to be able to put the Common Source Library onto international ships, LCS, Coast Guard, Aegis Ashore, and build in that flexibility that really gives us that scalability into the future.
As we deal with cyber threats, as we deal with high-speed threats, smaller radar cross-section threats, the various components of Aegis are also evolving.
That's exciting. We're introducing things like laser weapon systems on board ships now. It's hard to predict what the future will bring, but we'll keep coming up with new technologies and new processes and enable us to stay ahead of that threat.
When I look at the future of defensive warfare, Aegis will be well suited and well positioned to adapt to deal with an ever evolving threat.
Of course, the last picture, what was the last picture that they showed? Anybody see that one? It was a
Sunset with a battleship.
a battleship. I was like, what? What the hell? Yeah.
Probably the Missouri in Pearl Harbor.
Yeah, no doubt. I mean, we've got a couple other ones. Yeah, I thought it was a nicely done video of we got to modernize. We have to be a scale. There's new threats coming. There's new capabilities we need to install, and we can't use a monolith to get there. So this is these are the green slides of the presentation that basically shows what the future should look like. So yeah. ICS opportunity, the integrated combat system. The ability for 100% of the fleet to receive the latest capability on demand. The ability to outpace the threat. 100%, so that they're at 10% now, they want to get to, if there's a capability that needs to be given to the entire fleet, we should be able to do it with a push of a button. That's where they want to go. Elaine?
Yeah, just one thought coming from, the fact that we're pushing for software-based upgrades and development and microservices. One advantage, though, I think that maybe IWS might need to consider is the fact that, whenever they do a monolithic architecture and they do an install like that, there's usually a greenfield that happens with the entirety of the baseline itself. And I don't know if IWS is considered yet that if you're doing these microservices and the compatibility and the function that goes into creating these microservices, how that risk increases technically when it comes to, just doing one at a time and how that impacts it. I see it with Canes a lot. So
yeah, so she used a term called greenfield. So greenfield basically is start from scratch, build the capability from scratch. Forget what you've done in the past. I think this is more of a brownfield event. I think they're going to try to break the monolith into discrete components. There's some advantages of that. There's a lot of disadvantages of that because maybe you're not for sure how this is all connected. It may be more effort just to do that than just write code. I don't know if they're doing a greenfield or a brownfield. I have a feeling they're doing a brownfield. And but but yeah, that's a good question to ask them if I can ever get them to talk. It's a big budget issue here too, right? You're spending $1.1 billion just to basically refactor and re-architect the entire combat system. That's a big bill there. But this is the reason we want to go there. You know, it's like, hey, if there's a new threat on the horizon, let's just say small radar cross section, these drone swarms and stuff. Right now, our combat system is probably tailored toward an object size to prevent false targets, right? You don't want to track seagulls or anything like that. So this could be something that you need to push real quick and change the radar cross section alert because of drone swarms. Who knows? That type of stuff. A story that I have, we were deploying to the Gulf, going through the Straits, Hormuz, going into the Gulf, and actually going in, we didn't have a problem. Coming back out, and we were going to Yemen to do the rescue on the coals when we had the problem. But we're going through. I had a Marine Stinger team up on the top because we didn't have a small missile that we could shoot at small aircraft and stuff. So the Stinger team's up. He's sitting right next to me on a salt and pepper line. I'm not talking about, you know, that's how they're communicating. He's sitting next to me. We're coming out, and on the Tarawa, the bridge and combat were a stare away. And Skipper comes down, Captain Hall comes down. He says, "You gonna do anything about that helicopter that just overflew us?" I'm like, "What helicopter?" And I was like, we're like in wartime steaming. We are manned to the teeth and everything. And I didn't see this helicopter overfly us on the combat system. I was like, I don't see anything. I don't see any, I had to get up out of my seat and walk to the bridge and see it. It was an Iranian helicopter that overflew us with the door open. And this guy's hanging out with this thing that looked like this. And I was like, oh, he has a video camera. He's taking video of us as he overflew the ship. And I was like, what the heck? And so come to find out that that the radar system, the 48 Echo radar system that we had, filtered out any tracks below 200 knots. Never reported it to the combat system, never displayed it on my screen. Somebody made that decision way back when that we were going to do this weather filtering thing. So there, obviously nobody would ever try to attack you going less than 200 knots. I did not realize that. I guess I could have probably figured it out. All-time landing helicopters going less than 200 knots, but I never realized it. So anyway, the Marine guy, he finally says, "Hey, request permission to shoot the helicopter with the Stinger team." They were ready to go, and I was like, well, unfortunately, they're not. Even though they're over, it's international airspace. They can fly wherever the hell they want. But he's taking video. We're not going to shoot that one down. Not right now. So that's what we're talking about. We're talking about changing capability at the tactical edge based on the threat that they're realizing. Yeah. Delivering and developing and delivering capability in 90 days. And this is the pipeline, the software development pipeline they're talking about. They're talking about DevSecOps. They're talking about from developing the software, getting it certified, and getting it out to the fleet in 90 days. Hardware, a continuous development of the hardware pipeline. If you break software away from hardware, then they're independent paths. Right, I can continue to add software capability as I need it, and it's not dependent on the hardware it's going to operate on. That's the power of a modern architecture that is not dependent on the hardware that it runs on. A lot of advantages here. I'm able to provide iterative delivery of software to all capable platforms. I can accept and act immediately on evolving missions and performance problems and threats and priorities and fleet feedback. I'm able to react to that. Sounds like Agile, doesn't it? Continuous certification, continuous authorization to operate. This is the DevSecOps part of it. Continuous everything, continuous certification is built in to the process. It's not, let me develop this and then give it to somebody and hopefully they get it back in time. No, that's not what we're talking about here. So from a hardware perspective, all the good things, getting rid of diminishing manufacturing sources, basically because I can use any type of hardware as long as it meets the specifications. It doesn't really matter a particular chipset or anything else from a particular manufacturer. Biggest advantage of breaking this hardware apart into modules and open systems architecture is I can do this peer side. I don't have to have a CNO availability. I do not have to cut a hole in the ship. I can hatch it. I can basically come down the ladder well into the ship via that method, vice cut a hole in the side of the ship. So I can do a continuous maintenance availability type of stuff. Big deal. Where they want to go. Affordable to proliferate. So they're having to convince everybody spending $1.1 billion to get here is when you look at the future, that this is going to save us money in the future, and this is a return on investment discussion. I can deploy one development effort for all the surface fleet. All the surface fleet basically gets one baseline. I have one element integrator effort for all surface fleet. We're not talking about subs. That's what they're trying to tell you. One accredited computing infrastructure, one combat system for all fleet. One. That's it. Everybody gets it. Once it's decoupled in the future, you basically everybody gets the same capability wherever they are and whatever it is they're doing. They get the same capability. That's the future vision. Don't get confused. That's not what it is today, but that's where we're going. So what's the big advantage in this? I get higher quality software. I get user satisfaction source of increase because they're engaged. I'm able to fix software problems as they come up, and I can basically get rid of technical debt. Refactored software, eliminating technical debt. So when they say refactored, it sounds like it's a brownfield event, right? That's sort of where it is. The ability to do 24-hour delivery for emergent fixes. Continuous updates, capability with continually updated capability with users included in the development cycle and the common training pipelines across the Navy. Right now we have all these, depends on what type of ship you go to, the enlisted people that are doing the maintaining of this is what school they go to. So they have all these different schools set up based on the hardware configuration and the software that you have. So if you go to a baseline 5 ship, and then 3 years later you go to a different version, they got to go through Delta training. So get rid of all that. So this is their focus is to proliferate a high quality capability across the fleet at the speed of relevance. Okay, so that's sort of where we're at talking about this stuff. Slides together. I just broke them apart in little pieces so we could talk about them. If I just showed you this, you would sort of get lost. So this was their it's distribution D. That's the reason I can show you this. And so this is where we're going. Any questions or comments on this this combat system development of the future?
I would just say that this isn't, I know it is the future, but it seems like we're living in some of this already. So I just threw a comment in talking about F-35s, and it really seems like we've made this shift, particularly in the F-35 program and how we are incorporating software and keeping it separated and having the ability to reach out and provide a capability to the warfighter, today within 24 hours. And yes, absolutely, long live Odin, the very delayed software there.
Yeah, I would argue that the F-35 isn't even close to this. They right about the start of COVID, they were doing trying to do C2D2 was Admiral Winters, who was the PEO at the time, basically said, we're going to do this, we're going to modernize the way we do capability, we're going to do agile software development, blah blah blah. They gave it to Lockheed and they terminated the program after 2 years of trying to do the Block 5 upgrade and stuff. So F-35 not a really good example of being modular or being adaptive right now. I haven't tracked them. I haven't seen anything in the last year. I think they're probably going to try it again, but it was a culture thing, right? The PEO Joint Strike Fighter PEO basically said, yeah, we got to do something like this. So as new threats come up, we're able to do it and modernize and do everything like this. And so C2D2 was I can't remember the acronym, I apologize, but it's a continuous capability. I don't know, I can't remember. What is it? Anybody remember what C2D2 was, the acronym? Yeah, it doesn't matter. But anyway, it was a culture thing, and then COVID thing, and then it was a Lockheed Martin thing that they weren't really tooled to do to do agile and all this other stuff. So it was just a big disaster. Randy?
Yeah, Lewis kind of put it in the text there, but if we put all our eggs in this one basket and it's hacked or it's compromised in the fight, don't we have a greater risk than even if we had a couple of different systems that were a little bit less modular? Over.
No. I'm going to prove to you in the next several weeks the cybersecurity and the resilience that you get out of this modern architecture. You're gonna learn this, and you're gonna come out a believer. I believe at the end of the quarter, that you're gonna believe that containerized applications and microservices are much more secure and have it built in to identify if there's an attack, and also gives a built-in response to the attack by having things separated. So today, if a monolith is attacked and they're successful, the entire monolith is compromised. If a container is attacked and compromised, the entire system will recognize it and basically isolate the attack to your email server, like on Canes. So if somebody is able to get in, if somebody gets into your email server on Canes, then okay, fine. Just don't let them get into the rest of the stuff. That's really the important part of this is okay. So, but I want you to sort of believe me that this is really where we need to go, and you build in the cyber resilience in this. Okay.
Okay.
Just press the I believe button for now. I'll trust me there.
Sure.
Matthew, go ahead.
Yeah, no, Professor, I was going to go back to that slide of the where we want to get to, and I guess I'd like to hear thoughts on, my experience as a program manager and trying to get at this. I think we do a pretty good job now, or trying our best to get into the discussion with requirements and design office. But when it comes to implementation and the design, we're so heavily relying on the OEMs and what's out there today, from especially COTS software, that we don't own, nor do we want to own, but we ask them to do things that they're not able to do. So the struggle is, or where I've been finding the even equally or hard part, and I guess I want your comments here, is it's a cyber offices leadership wise and ATO process that I'm just struggling with continuously when I get through it through IATT, so interim authority to test. I've done probably that a little bit too freely. Don't quote me, but it's a really hard time for me when I try to do some of these things, and then the cyber ATO process is almost like a speed trap for me. It's like I go fast and it's like, no, stop. And then once we go through the process, it's, especially for aviation, it's incredible hard. And I was doing a lot of stuff with drones for my background.
Yeah. So it's a culture thing that we have to deal with, and it's a process thing that we have to deal with. We have to get them to believe that our process, this new process, this DevSecOps type of thing, we have to pull them left with us. And we have to pull them into believing that the software quality and everything is much better than the old days of delivering a monolith. We have to get them engaged and do ATOs sooner and have continuous authority to operate based on some sort of belief that this is the right way to do it.
Sir, I mean, to touch on that as well, the fact that, continuous ATOs in, industry, if you're looking at, the way that, and going back to containerized software capabilities, the idea of doing an administrative process of what we do in the Navy is obsolete. I mean, the Cato concept that, CISA employs, DHS, is where the system updates according to what's in place, as opposed to having this long, drawn out automated process. Yes, you could dive into it if you wanted to, but to have that just sort of self-sustainment and refresh through software and containerized systems, that's really the key. I mean, just remove whatever container you have and implement a new system that's updated and accepted to the network. That's the driving force for all of this software acquisition, as well as Cato.
Yeah, yes, and we will talk about this in the future. That it's a spot on point. So we're going to talk about the modern architecture, okay? And the modern architecture is little pieces of containers of capability that basically is orchestrated to give you the ultimate capability, what you need. So if we're saying we want to add something and some capability, we're talking about a container. We're not going to touch any of the other stuff around it. We're only going to do this. So if I need to get an author, if I work this right, if I have an ATO organization, I can focus them. It's like, I didn't touch anything else. All I touched was this container. So if I'm still stuck in this old process of having somebody come in and look at it, fine. That should be very short compared to looking at the monolith, because God knows what you touch. So it really is it is a process change that we have to go through. It's an understanding that we're not changing everything. We're only changing a container capability, and that's all you need to look at if we're still stuck in that process. We believe with a modern architecture and modern software development practices, DevSecOps, we believe we can convince the ATO people that to take the risks that allow us to push out that capability in a short duration amount of time. So when we say 24 hours, and in the Aegis world, they own that process from beginning to end. So it's pretty easy to convince themselves that this is a very sound process. Challenges is like if you want to go onto the network, if you've got an IT system and you now want to deploy a new capability, there's other people that own the network and they have a different process. So it is a lot of we got to come together and for everybody to understand the value of this and what we've changed. And that we're changing from a monolith to a containerized microservices or virtualized machine, if that's where you want to go. So what I'm trying to so this is like a prequel, right? I'm giving you this of the urgency and why we need to make these changes, and we're going to spend the next several weeks about what is it we're really talking about, what is it at the way it's connecting. So it really is a value. So CANES is a weapon system. Consolidated a note. I'm reading the chat. Consolidated Afloat Network Enterprise System is an IT system that is on Navy ships that basically does your email, does your print servers, does your network on the ship from a C4I perspective. Okay, it is not the weapon system. It's Aegis combat systems or ship self-defense system is an entirely different network, and they are not connected to some degree, unless you go through ADNS or some. How do you get off the ship to communicate via the network? And then there is a connection, I guess. Okay, so these are slides worth looking at. We may revisit them once you know a lot more about modern software, but that's sort of where I wanted to get you today. Okay. It is a big deal when we look at how are we going to modernize. What is it that we need to do? What culture things that we need to change? What process things that we need to change? I'm saying all this change stuff. Remember, I showed you the Cottier model, the steps that basically said, hey, you know, we have to have a sense of urgency why we need to do this, and it's you know, an adversary that is out there that is able to change faster than you. Exploit you, defeat your capabilities. This is the reason we need to make a change, especially in the combat system. So let's take a look at the 10 Commandments, and we'll finish up today a little bit early. This came from the Defense Innovation Board. This is the document. If you haven't seen it and you haven't read it, it's I think it's about 200 and some pages that they wrote. And it was a different way of explaining what needs to change in the DoD in order to make an impact and to become more modern and stuff. So that's sort of where the genesis. This is a 2019 document. It was delivered to Congress. Congress said in the National Defense Authorization Act, go do all this. Go do everything that they said. And so this is the guiding document within the DoD. And as we start looking at the tools and things they say that we needed to do, they said, you know, we got to be able to develop and deploy software as fast or faster than our adversaries. Our adversaries are using modern software development stuff. They're using the tools that are in the commercial marketplace. They are developing their capabilities using modern software development methods. If we're stuck on waterfall and we're stuck on monolith, we are stuck in the past. So that's sort of the pitch here. That's the reason you need to understand a monolith. They're able to build on commercial available tools and technologies and steal their way to where they need to go. They basically recognize that software is different, and it's a good distinction. They go through and they try to explain different type of software. We have off-the-shelf software tools that we're going to be using, a sort of off-the-shelf. I'll show you a bunch of tools that we use in the software factory to non-customized software to highly specialized embedded software, all this stuff that we have out there, and we need to make sure that we understand and have the right tools and methods to go about everything that we need to go to do. Yeah, thanks for the link. So they try to set the stage, and it's the things that we've been talking about is that we're concerned that we're being outpaced by China in particularly, and we have an industrial error planning tool, programming, budgeting, the budgeting method problem that we have. They recognize that, and so this is a big deal. And we are connected to the method and the budget. This is sort of the fact that this is sort of where we're at. Commercial software, you know, they talk a lot about this commercial software. In the commercial marketplace, there's no delineation between their development process, their procurement process, and their sustainment process. It's one continuous cycle. They're all the time revisiting and because the user is always demanding new things and new capabilities. And they're able to deliver new capabilities in months to weeks or even days for critical updates, right? It's the software that we live in the commercial marketplace, right? They're trying to dominate the market. They're trying to get money. That's how they make profits. That's sort of how it goes. So that's sort of their motive. And, you know, they start asking the question, why does our appropriation structures make this difficult to implement the approach in the DoD? Why are we so broke when we look at the commercial marketplace, our commercial marketplace, and the value that they're able to do? Our adversaries don't play by our rules. They're able to exploit commercial technology, and they basically can develop new tactics and new capabilities that's going to be used against us. And we're going to be stuck with a monolith that can't be changed. So this is what's driving it, right? This is all in this document. They're basically saying we need to think differently. We need a cultural change. We need to be able to rapidly develop and deploy software into operational environments. We need to deliver capability to deployed ships and deployed units where they're at the tactical edge. You need to be able to do that. Well, you need to have an infrastructure that can do that too. So we're sort of saying we're hopefully we'll still have satellites during a conflict with China. We're hopeful that we're able to deploy software when we need it, but that's sort of where we're going in an operational environment. We need to develop software using automation. We need the automated tools for testing. We need automated tools for updates, how to deliver patches and add new functionality, right? This is what we're talking about. We need a new framework to develop software in the DoD. We need to change the way that we're developing our software. So that's all the stuff that we've talked about. So this should sound familiar with what we've been talking about, right? It sort of came from these documents in the past. So let's look at the 10 Commandments. And they were having fun with this. Look, you know, everybody should recognize, you know, from a history perspective, if not the 10 Commandments. They said, let's give 10 Commandments and let's see where we go on this. So do not constrain your development environment. Make compute, storage, and bandwidth abundant to DoD developers. And we're talking cloud, we're talking platform one, we're talking the Forge, that they should not be resource constrained in their development capabilities and the users. We gotta modernize our hardware infrastructure, and we gotta make sure that the capabilities that we give them in the future that they're able to exploit and use all this stuff. This one is pretty obvious. It's really, hopefully it didn't start off as 15. Yeah, who knows? I think they had a lot of good ideas. They basically said, all software procurement should start small, be iterative, build on success, or be terminated quickly. That sound familiar? You guys heard this before? Last week? Yeah. If you don't get to minimum viable product in a year, once you start execution, once you get your funding, you should terminate the program. This is what they're saying. Starting talking about budgets, we need to start thinking about software as being immortal, as being never done. We need to have our budgets constructed that we're basically making sure that we're able to fund this stuff in the future, and in order to maintain the software and the utility of the software as long as it lives. So there's a budgeting problem, and we need to figure that out as far as the life of the program. Matthew?
Yeah, I was going to ask if anyone in the classroom has any updates or maybe just experience with the PPB&E Commission and the recent work to a few software groups with their different, uncoloring and, software funding. It seems to be their focus around a lot of these efforts they're trying to do right now into this new colorless, moneyless, not tied to any, specific budget line approach for certain budgets to software. Any experience that in the group?
Yeah, the BA08 is the pilot that they've
Yeah,
done.
that's right.
Yeah, last couple of years, and from what's the words? So from a how does it feel? Does it feel like it's better not to have colorless money? Everybody says this is better, but the metrics aren't really showing the value. Simply because the pilots that they're using aren't in the deployment continuing upgrade phase. They're sort of in the left side of development, to where they were getting RDT in anyway. So the problem with money, the color of money is what Matthew is talking about, is if you today, if you put software out there and you say, okay, it's certified, it's good to go, the only way we can maintain that software is with O&M money, operations and maintenance money, okay? And there are specific rules for O&M and procurement dollars that you cannot add any new capability using that funding. If you want to add new capability, you have to use RDT&E dollars. And that causes a big financial management configuration there. Like, maybe that's a word. That now we're, it's like, is this an improvement? Well, hell yeah, it's an improvement, right? That's the whole process. That's the reason we're doing this, is continuing to add capability. Well, that must mean I have to have RDT&E dollars. Well, what if you're just maintaining it? What if you're, the infrastructure to maintain it and all this other stuff? That's O&M dollars. And it just gets like, why? Just give me money and we'll do what we need to do. So that's what BA8 is about. And they did not add any new programs last year. They would not let them authorize because they're not happy with the metrics that are coming out with it. But there's groups that are working on it. I've talked to them and stuff. I wrote a paper on it for ARP, Acquisition Research Program, for last year. So in May of this year, we're going to have the Acquisition Research Symposium. And one of the panels, I'll be running the panel on software acquisition, the good, the bad, the ugly. So we'll be talking a little bit about this. But yeah, I think the PPBE panel is going to come up with a bunch of recommendations, but we'll see what comes out in March. And hopefully some ideas is why, if you're really not for sure the capabilities, why don't you just give SecDef or somebody a pot of money to where they're able to break the FIDIP cycle that we're in, 2 years, future planning, blah, blah, blah. Why don't you just give them a gob of money and let them be responsible and accountable for this money? Initially, they did that in 2019. I think they gave the R&E director, gave research and engineering, gave them a pot of money, but they didn't continue. So we'll see what comes out of it. But yeah, budgets is a big deal on this, if that can't be overstated. Adopt the DevOps culture for software systems. GA Verily, we're going to look at that. Now they say DevOps. So in the commercial marketplace, they call it DevOps. We're like, well, security is really important to us. So let's call it DevSecOps. Let's bring the security people into the picture. The DevOps people, the commercial, they're like, well, we always worry about security. We're always worried about testing. So what DevSecOps test, blah, blah, blah. So anyway, we settled on a name. It's DevSecOps for DoD, and commercial industries like, yeah, okay, let's call it that. And this is the automated testing, deployment of software for critical updates and in days to weeks, not months or years. Said, yeah, you got to be fast. Okay, fine. We need the source code. If it's built for us, we need the source code. Intellectual property. Okay, fine. If it's built for us, give us the source code. That way we have it. And if we need to modify it or we need to bring in a new contractor to add capability, we have it. Okay, all right. I think that's fair enough. The problem is things start getting convoluted, right? You're just like, well, somebody that built it, they're using some piece of proprietary software that they're adding, and then we got to let the IP people sort of figure this out. But we got to make very clear that we have to understand that everything that was built for us, that we get the code. All right. Let's see here. every system that has software, there should be a local team of software experts that are able to modify and extend the software through source code or API access. This is an interesting one. I haven't seen very much being done on this one. The Army has a software factory in Austin, Texas. They are training. They are training enlisted people through a cohort how to modify and change software at their environment wherever they go, and it's really weird way they're setting this up, and they're like, well, what happens to these cohorts after they finish their time in Austin? Where do they go after that? And they're like, into the wind they go, and it's like, so anyway, we're still trying to work this out. Elaine?
Yeah, so data science at sea, which is a new line of effort that the Navy is trying to implement, that's part of that, where you get data scientists and enlisted that have some background in coding and trying to, create some level of, a silo within itself to create that. And then also the maritime cyber warfare community that's just being started up. I think that they're trying to grab at that too.
Yeah, I think it's from the API perspective of creating code, not getting into the source code and changing it. I think it's more on the external already built in. Mike?
Yeah, so I think you may have just answered it, but my question is, like, how do we maintain version control if we start allowing people to mess with software at a local site?
Yeah, I think messing with the source code is probably a bridge too far where we're at, and I'd agree. But API access is it's meant to be that way. It's meant to be able to add capability through some sort of application program interface or whatever API stands for. But yeah, that's sort of where they're going with this. Only run modern operating systems that are receiving and utilizing regular security updates for new discovered security vulnerabilities. I would say that is absolutely what we've done in the past. Ships at sea would receive a patch, and we would basically do a security update on the code, especially on the IT networks. We've done that for quite some time. Application programming interface. Good, I get that close. So yeah, I think keep your systems up to date with and close the vulnerabilities as they come up. So yeah. Yeah, data should always be encrypted unless it's part of active computation. This is data at rest, should be secure and encrypted, so it can't be exploited. So absolutely do that. And for the most part, I think we sort of do that in the DoD. This one's an interesting one. All data generated by DoD systems and development operations should be stored, mined, and made available for machine learning. I say AI too, right? This is just a couple years ago. We throw away a tremendous amount of data, especially at the tactical edge. We just don't have the storage capability for it. We just don't know what to do with it. So this is a big deal. I mean, I can talk about this. Operations at sea, we're collecting all this data, what looks right, what does normal look like in a normal day, and then have some sort of analysis of this and have a trigger. So if something looks abnormal, the operator, there's a flag that's basically say, this is different. For this time of year, ships don't act like this. The adversary doesn't act like this. So anyway, there's some of that. So where are we? This is from 2023. This is the last slide up too. They basically said, the GAO said, hey, how you guys doing on these 10 commandments? So they basically reported in this report that 4 of the 10 have been fully implemented. And 6 of them have been partially implemented. So they're tracking this. So those 10 commandments we just showed, I don't know exactly which one's the 4. I mean, you can read this report. There it is. It's 23, 10, 56, 11 is the report. I think it came out in November of last year. So they're interested in this. Well, how are you guys doing on this? So I think this is a big deal. So that's the 10 commandments. I think it's good that they're tracking it. I think these are good things that we need to sort of go to and get us to where we need to go.